My name is Seth Grannan. I am a senior solutions consultant for Theoris. I'm on the solutions team. And lately I've been primarily responsible for spearheading our push into cloud, whether that be AWS or Azure. And I've been really working on developing frameworks for our clients around using RESTful APIs, microservices, and a lot of the best practices associated with those technologies and those stacks in both .NET and Java. So today, obviously, this is the .NET Consortium, so I'm going to be talking mostly about, all about .NET and developing microservices in .NET Core, as well as tying it all together with a front-end web application. So to get kind of started here, the overview, basically, I'm going to go through a few quick slides, probably about 10 minutes worth of a talk, and then we'll get into code, looking at Visual Studios, looking at Azure services, and deploying to the cloud and trying to leverage some of these microservices. So first things first, I want to talk a little bit about the microservice architecture pattern and its pros and cons. Everybody's probably used to seeing, I think last time Ari went over actually creating a RESTful API and how to leverage a RESTful API. Well, this is going to be how to tie APIs into a service and multiple services together. So when you're thinking about that, one of the pros of a microservice is its scalability. When you're running a microservice in a container app up in Azure, for example, you have the ability to tell Azure to scale your service based on demands on that service. So you might have 3 different services, but let's say you have an order service that's under heavy load. Azure can automatically scale that particular service, add more containers, and then scale back down once the load decreases. One of the other pros is data sovereignty. That essentially means that each microservice should have its own database, essentially managing its own set of data. This allows you to isolate and keep things very flexible, and also goes along with the scalability too. As you add more load on the system, database, you can scale the database as well. Thirdly, independent development. So a lot of us here might be familiar with Agile or Agile practices, where we all are in or on separate development teams. One of the biggest, I think, advantages to microservice approach is you can have different teams working on different services independently of each other. So you're making better use of your resources. Lastly, one of the high-level pros is an isolation of issues. So if I have 4 different microservices and I encounter a problem with my customer data, for example, it's not necessarily going to bring down my order service, inventory service, or whatever services I might have associated with my front-end web application. So I can fix that issue, push that fix through QA and the build pipeline, and get that out a little quicker with potential minimal, lesser risk than I would be if I had a monolithic application. Some of the cons of a microservice architecture pattern is it's definitely more complex. There's a lot more complexity that can be involved depending on the business needs of your enterprise application. There's a higher tech level of ability required. It's kind of, when you start out, you really need to sit down and think about all the different types of services you may need. Because the third thing is partitioning future services. Could potentially become a problem if you have published a set of microservices that are being leveraged by a client, but now all of a sudden you identify the need to split one of those services into smaller services. Now you have an issue of how do you handle client traffic to those endpoints, right? So with all that said, this diagram here is kind of what I would consider almost like the holy grail of microservice architecture patterns. You can clearly see that you have on the front end your client applications, whether that's a mobile application or a traditional web app, or nowadays you might see progressive web apps or single page applications. And then moving down, you have essentially you have your containers and your Docker host. These may be, nowadays you have the ability to leverage things like Kubernetes or Docker Swarm to group your services in containers and run them in the cloud. You can also leverage an API gateway, something like MuleSoft or Apigee, to essentially add governance to your services and drive your traffic through to put all sorts of, whether it's authentication, authorization around them. And then you have your services themselves all broken up into their individual containers. And on the back end of that is what they have pictured here is what they're calling an event bus. It's basically could just be event-driven, essentially event-driven services communication between the different services. A couple examples here are RabbitMQ or Azure Service Bus. So that might for example, that might handle if you've got an order processing system that might take orders and push orders to your shipping system or something like that. No human interaction required there. So for this demo, I'm going to focus on 3 services. I've got a customer service, an inventory service, and an order service. I'm going to show you basically how to, since we covered last time how to create a RESTful API and everything, I'm just going to focus on deploying, modifying a service, deploying it to the cloud, and leveraging it through a front-end web app that I've got that ties all these 3 together. So one of the things that you have to consider in this approach is you got to containerize your apps. So it's going to require, for my examples, I'm requiring Docker, and you'll need to be able to create and run these containers locally. One of the things that Visual Studios, I think, handles pretty well is adding Docker support to a project. Visual Studios will scaffold and create Docker file for you, as well as publish profiles, and handle the entire build process that results in a Docker image. And then lastly, one thing to keep in mind is you may need to customize your Docker file based on to reduce any security risks or specific deployment needs.
Excuse me. Are you usually in charge of taking care of those security risks, or is like the network or system administration level person taking care of this?
I'm actually, since I'm part of the solutions team, I'm actually the one that's responsible for that. So we're identifying, we usually stick to best practices and we identify any potential risks, but sticking with a lot of the best development practices kind of eliminates that. So, larger enterprise applications and larger companies, you probably have a security or network team that does pen testing or identifies any potential risks there.
You're talking about containerization.
For our containers, the reason we went with containers is just customization, specific images. We're running them in the apps that I've been developing more recently. It's been a lot on the Java side, so this is the first time I've really done with .NET. I've got a lot more customization when it comes to my Java applications, and I'm running on a different web server anyway. I'm using like Tomcat as well. So Azure has a lot of different services to offer. You could run, APIs in Azure Functions. It's kind of similar to AWS Lambda, but for the purpose of this, I'm just sticking with containerizing the apps. So as for deploying to the cloud for Azure, there's a couple things you need in Azure to be able to deploy an app. The first thing you need is a Azure Container Registry. This is basically a repository of all your Docker images. Second thing you need to do is in Visual Studios, you'll create a publish profile, which is simply using the publish option. And it walks you through a little wizard that allows you to specify options about your container and your registry. And then the third thing you need is in Azure, you'll have to set up an app service plan and decide on creating an app service. The app service plan is responsible for the resources that your containers use, and then the app service actually is where your container, your microservice will be deployed, and your image gets run from. So I'll finish up with this slide, and then we'll kind of walk through everything that I just talked about. Tying it all together, I've got in addition to the three services I mentioned earlier, the customer service, the inventory service, and the order service, I've got a simple, fairly simple .NET Core web store, web application that's basically like a store. It calls each service independently and then leverages the data returned from those services to make other service calls and get more data. So with that said, let's dive into some of the code. So one of the services I mentioned was the customer service. I've already took the liberty of scaffolding out the service basics. Is that better?
Yeah.
Cool. You have the solutions for so since I scaffolded this out already, I didn't want to spend the time taking to kind of detail typical application structure. But basically, I have some controllers for endpoints, a few models. I've got and then I've got a data project that actually is responsible for the communication to and from the database. And then I've got some repositories that I've created that will be handling fetching my customer data, as well as user data as well. So one of the things I talked about was adding functionality. So I've got this customer service here, and I've got a controller, but there's no real code, right? So what do I need to do to expose an endpoint? I simply just need to I'm going to add a method here that calls my repository, gets my customer by a customer ID, and then returns that customer as basically a JSON from the API back to what will be the web store app. So so this doesn't exist in the cloud right now. In order to push this up there, one of the things we talked about is you've got to be able to publish this app, right? So I've got my Docker, I've got Docker support added to this project, and when I do that, it creates this Docker file right here. So Visual Studio will scaffold you this Docker file and basically figure out what is in the structure of your project so it can create your image. It uses a base, when you're using .NET Core, it uses a base image from Microsoft that they provide to you. I'm using it's .NET Core 3.1 SDK, which I think is the latest. And that's basically what Visual Studio will do for you whenever you tell it to add Docker support. So it's pretty self-explanatory, pretty easy. There's not a lot of manual thing that you have to do if you're just going with your vanilla service, right? So in order to publish my service, now that I've added my endpoint to get my customers, I need to be able to set up my Azure app services and app service plan. But before I can do that, I have to publish. So I believe I've connected it already to my repository. Yep. So down here, you'll see the summary. Let's see. So I've connected to the repository actually already. I've got my image tag as latest. My repository is our Theoris, is from our Theoris account, and I've set, configuration to release. So that all comes from your Azure services. So up here, I'll show you real quickly that I've got a Azure Container Registry, and this is the container registry that I'll publish your service to. So if I come back in here and click the publish button, Microsoft is going to take care of a lot of things for me at this point. A CI/CD pipeline, this is probably where your DevOps team would get involved. You would instead publish this code to your repository. It would kick off a build. This build would essentially do what Visual Studio's MS Build's doing right now, create a Docker image, and publish that to your to wherever you've got your app hosted, your image repository hosted. If I give this a few minutes, we'll see if it publishes.
Question.
Sure.
This might be a silly question, but that Docker file, is it being processed on your local PC or up in Azure?
It's part of the build. It's being processed on my local PC. So it's part of the MS build process. It actually, whenever you installing, one of the things I talked about is you have to have Docker installed on your machine. Doing that, we're invoking the Docker build process. Docker build process uses this Docker file and uses these commands in the Docker file to know how to create your image.
So every time when you are running it locally, like debugging or whatever you are running it for, it will be running it inside the Docker container?
You have the option of running it inside a Docker container. You can run it, if you guys are all familiar with Visual Studios, you've got several options up here at the top, typically when you go to run your solution. In this drop down here, I've got the ability to run it through Visual Studios. I've got the ability to run it, never find in my Docker container. And I've got a few other options too, I believe, right? There's IIS Express, and then there's a couple other options I haven't really explored. So, but if I do choose Docker, it will run it as a container. If I hit I can run it right now, and I'll show you. Actually, one of the nice things that Visual Studios does is it recognizes your Docker install on your local machine, and it will show you when you're running Visual Studios, when you're running a project in Visual Studios. It'll show you your images and your containers and everything here in Visual Studio. So it's pretty smart. They've got a pretty good integration with Docker. So you can see everything that you've published, and you can also see any containers that you've got running. Right now I don't have anything running. So,
So when it's running the .NET Core 3.1 SDK on Buster, is this, when Microsoft writes these Docker files, are they using like the optimal Linux image so it's as lean as possible in your registry?
I mean, one could assume so. I just kind of using whatever the vanilla image that they're giving me is. That's not to say you can't go tweak this. So what I do for my Java projects is I go tweak this. Like I go get a specific version of something that runs Tomcat, right?
Okay, there's a spare battery. Yeah.
This is kind of, when you add the Docker support to your project in Visual Studios, this is just what they give you. So this, again, goes back to what I was talking about earlier. This is the customization or tweaks to your Docker file. You might have, a DevOps team that has specific images that you're allowed to use, or they might have some beef with you using something too bloated if they've got only so much container registry space, right? Because all of that, the more space you use, the more money it costs, the more bandwidth you use on your published, the more money it costs. It looks like that app went ahead and published. So one of the things I can do is if I come up here to my dashboard, I go to my app services, you can see I've got a build out of quite a few services at this point. This is the particular app service for the customer service. When I do a deploy, because this app service targets that specific image that I created, I don't have to do anything else other than doing a deploy at that point. It will have done in the actual container configuration. Settings, sorry. In the container settings, I actually set the image from the Azure Container Registry and tell it to use the tag latest. So this, one of the strategies I've used for some of our customers is I've started tagging our builds with like dev, test, stage, prod. So you can have all sorts of different services, app services up in the cloud for your different environments. And as you progress through your CI/CD pipeline, you create the specific builds with specific tags, and it automatically updates your environments. One of the things that you'll see, you'll be able to identify when it has pushed an update to a particular service, or because you'll see some logs appear that talk about how it's pulling the image, and usually those are time-stamped with about the same time that your build finishes. Essentially, if I was working in small teams or or my team was just responsible for the customer service, I'm basically, I'm done and I can move on to the next thing, right? Now it's on my front-end web team to hook up to this customer Git endpoint and make use of it, right?
Excuse me?
Yeah.
So could you explain why the microservice architecture doesn't carry into the front end? Like, why would you not have per service, a front end person on that specific endpoint?
You could. I mean, I don't think that there's any reason why you couldn't split that up. It just depends on your organization. There's a couple different ways you could essentially architect your application and your environment for whatever reasons. We have situations that for like the solutions team that I'm on, where I work directly with the front end developer, or we work in tandem. So it really just depends on the architecture of your team. So that was so just publish the customer service. So if you remember, I've got 2 other services at this point that are all part of my microservice environment, right? So I've got an order service and an inventory service as well. And in order to bring all these together and actually make use of all these services in an application, I've got a small web store application right here that is just kind of a mock-up that pulls data from all 3. And so show you a little bit of the code of this, and then we'll go out there to the web and show you how it works. So from my web store application, I still kind of have a similar architecture because I'm using the ASP.NET Core Web. I've got an MVC type architecture. This isn't to say that you couldn't have a React app or Vue.js or some other, like I said, progressive web app or a single page application that leverages your services. For the purpose of this demo, I simply chose to keep it very vanilla and stick with a .NET web app. So in my .NET web app, the architecture that I've taken with this particular application, keep in mind this is the front end. So in my front end, I've got a services project that essentially leverages each one of my different services that I've created. I've got the customer service class, inventory service class, and an order service class. Each one of these services will leverage an HTTP, the .NET HTTP client, to make a request to its respective service. So I'm kind of encapsulating all of the data for a particular service, even on the front end as well.
So those 3 services, they are on 3 different containers, or they are on the same container?
So this is all part of the front end web store. So
but right on the back end, those 3 services, those are on the same container, or those are on
different containers.
different containers? Okay.
Yep, so they all have their own separate containers, and that's basically because, like I said earlier, if my order service might be under much heavier load than my customer service. I'm not seeing a lot of logins, but I might be seeing a lot of traffic from between like orders and shipping. That allows my order service to scale without the need to scale my customer service. Saves a little bit of money.
So they are going to be 3 different projects as well?
Yep, so they are 3 different projects as well. And so they can just, again, depending on your organization's architecture needs, you can, how you manage those in their repository is completely up to you. Since you asked, I'll go ahead and show you. I actually have all of my services under one repo in GitHub, right? So So these all, I push them all to the same repo and Git. But I can still work on each one independently. A PR in one service isn't going to step on anything I'm doing in another service, right? So back to the web store, you know, I mentioned that I've broken out each service individually, even in the storefront, and that allows me to make the HTTP requests to each service independently. You know, one of the things that you guys are probably learning about are, you know, all these requests can work asynchronously. So that only speeds up the page, my application even quicker when I can make all those requests at once and just wait for the data to return. So this is the customer service. I've got the inventory service as well. They're all very similar. And each one has their own models to handle and you know, translate the data from the API to whatever my users need to see on my front end, right? So then my web store has controllers that leverage each service. So you can see my customer controller here. I'm actually injecting, I have all three of my services as parameters for that particular controller, and I'm leveraging in the just the index page, the order service, getting customer orders from an order service, and then identifying the items in each order and making a call out to the inventory service to get the information on those items, right? And so in a few seconds, I'll show you what all that looks like from a front-end perspective. So while I get to that, I'll just show you that the web storefront is deployed in the same way that all the other services are. It's running up in the cloud in an app service under a Docker, with a Docker container. So if I go to that particular URL, it should load my data. So if you remember what I just talked about, that the customer controller, I'll show you what happens when I log. So this is just what happens when I load my web page, right? Gets a list of items from my inventory that I may or may not want to add to my cart. What I showed you earlier with the customer controller is when I go to log in, that's really where I start to leverage more than one service, right? So if I click my login button, as quickly as that loaded, it just reached out to both the order service and then the inventory service to display this data and pull it back into the view. So that's pretty much how you that's tying it all together, essentially. Again, very lightweight app. If I wanted to, I could easily have, so for example, in how you make changes to that, I've got a My Profile button here. Right now it doesn't go anywhere, but if I wanted to, I could leverage that customer Git endpoint that I just created and pulled back from Postman. That might be something that I would call when I click my profile, right? So that's pretty much everything that I had slated to demo anyways. Does anybody have any specific questions about anything I just talked about?
How does what you just ran us through differ from either whether this is the norm or this
I mean, I think a lot of the other options are, you know, you've still got companies out here that have like monolithic applications that just build out RESTful APIs. Those aren't necessarily microservices. Just building a bunch of RESTful APIs isn't a microservice, right? Because you still tied it all into one giant backend, and your code base you've got a unified code base with probably maybe a lot of different dependencies, right? I think you were next.
Yeah, that's actually kind of two. One, where's the data stored on that framework? So like you have the applications all sort of sequestered, but the data itself is stored.
So the data is in it. I've got a Azure SQL database. So with three different. I've got an Azure SQL server with three different databases on that server. So these are each one of those databases that I just pulled data from. Remember when I talked about data sovereignty? This accomplishes that, right? So I've got obviously each database named appropriately, so I can remember where my data, what service connected to what database.
If I can make a second question. If you were to break one of the back-end ones, I think you mentioned this in the slideshow, the rest of them would still function correctly because they are all like separate things running independently.
Absolutely. So, you know, where that kind of mentality, I guess, becomes most useful is if you have a client or a set of clients that are leveraging all your services potentially independently. In that case, you know, if you take one service down, it doesn't necessarily break all. It doesn't necessarily stop communication for everything. Obviously, with my web store example, if I took down the customer service, I would still be able to load this page, right? But I might not be able to log in.
And that also seems like it would be really good for portability, like in terms of moving it to a new project and keeping the same like backend.
Yeah. Oh, absolutely. I mean, I could even I could even change the back end. You know, I can move from SQL Server to MySQL, and because my services leverage repositories and the models stay the same, nobody really cares. I just change the connection string to different driver, right? And then I'm off and running. Go ahead.
In your demo, the front end is communicating directly with each individual microservice, correct?
Yes.
So, say at scale where you have 100 microservices, would you still recommend that approach, or would you have some sort of other solution?
So let me show you one of the things that I've seen. Some of our customers, they've encountered the same problem. Let me back up to the diagram a little bit, and we can talk about that. So I mentioned it very briefly, but one of the ways to handle that is with this API gateway. So you have a product like MuleSoft sitting in between your web store and your APIs to help manage that, right?
Okay.
I don't know if I can, let's see, maybe. It doesn't seem like I can. Yeah, it's all right. I can make it available. It's actually just from a link on Microsoft's website. I stole it from. Borrowed. Let's go back here.
Okay. Once again, on the containers, how do you handle like elasticity of the containers? Like, I mean, do you just add another instance of the container if you need more power?
I leave that all up to Azure. So that's one of the nice things about platform as a service. Nowadays I don't. It almost eliminates some DevOps people from my pipeline, right? In Azure, if depending on the service plane that I've selected, you can set thresholds So if your CPU rises above 90% for 5 minutes, Azure will automatically add container instances itself. And then you set another threshold that says, okay, when it's gone back to normal, start scaling those instances back.
Yeah, how the Kubernetes play with these containers? I mean, how do you orchestrate these containers with Kubernetes? You don't do anything with Kubernetes?
I actually haven't leveraged a lot of Kubernetes or anything regarding Docker Swarm or Kubernetes. Azure handles all that, so behind everything that we see here is, it's all running with Kubernetes in the back, behind the scenes. So I can't specifically speak to anything Kubernetes related. That's, not that I wouldn't like to get involved with that, but I try and, the reason I'm using Azure services and leveraging this is because I want to try and extract the DevOps piece of application development, right? Someone else had a question back here.
Yeah, so in the database, you have separate database for each of the services.
Mm-hmm.
So in this kind of scenario, the example that you give, you may have some data, those like relational data. How do you manage that? One customer and database for the customer, another database for the orders.
Yep.
So where do you store the customer order information?
So that's a good question because that's something you definitely need to touch on. And this comes into play really at the architecture level, like at the highest level. When you got to figure out what information you have. What I did was in my database is I have I have sequential IDs that are like my primary keys, right? But then I've got a customer ID that's a GUID. And that GUID, I've got constraints on my orders database that it's going to require me to, basically that field can't be null, customer ID can't be null, right? So I have to take my customer ID from my customer's database when my customer gets created and make sure that when they order something, I pass that as part of my request to my orders, to my order service, right? So that's in the contract essentially for that API.
So that is just checking for the null values, but there is no referential integrity there. So there could be an ID path if it is not related to any customer.
That's true, but again, if I bounce back to this diagram, that's exactly what I was kind of alluding to about the event bus piece of this. Essentially, what I would do, to help maintain referential integrity or make sure nothing got out of sync is, that can be handled in the event bus, right? You can design a service that runs to kind of handle your business rules or constraints or and making sure your data is still usable, right?
So what is the benefit of using separate database? Why don't you use one database in the back end while all the services pointing to the same database?
Imagine you've got 1 million customers, right? 1 million customers that each have 1 million orders. That's a lot of data. You can really kind of, that goes back to what I was talking about, data sovereignty. You really might need a much larger orders database with a lot more processing power to be able to handle some things that are going on in that environment compared to what you would need for your customers' database.
So that is still going to be the case because there will be some tables, those are going to be extremely large as compared to others. So your database scalability still need to be maintained, even though you have let's say customer order table because everybody is ordering so much. So that is going to be the biggest one. So even though you keep every table in a separate database, still your customer order still need to be managed on multiple servers.
True, but you may not need as much, you might not have to spend as much money on your customer's database as you would your orders. And your orders database, again, with the event bus, it might be connected to a shipping service. So if you run into, you might have heavy load on your orders database, but that's not going to slow anybody down from logging into your application, right?
In the other bigger problem is a single point of failure. If your DB is down, if all services are gone. But by keeping them separate, they can all work independent, as he said. One service goes down, still other can work.
Yeah.
But if you move everything on one single database, it's kind of all or nothing.
For that, you can have, the same database also deployed in multiple nodes,
No, and you could also have multiple of these databases deployed to multiple nodes too, right? I mean, it all comes down to your risk management. I was talking about isolation of issues earlier. So what is your company's risk tolerance, right? What is your disaster recovery plan? What level of, I always call it the red face test, right? If something goes wrong, how long is it going to take you to fix it? And who does it affect? And how big of a mess is it?
And one more question. So the DevOps part of this, how do you manage that? Because it seems like you are going to have tons of projects, tons of pipelines. So you will have pipeline for every single one of them?
Essentially, I would. In order to keep things manageable between your teams, yeah, sure, why not? I think that the smaller you can keep things, the more manageable they are. Being a consultant for the past 5 years, I've seen a lot of our clients with these big, giant, monolithic applications, and the cost of maintenance on those things is ridiculous. I think one of the most not fun things in the world is having to dig into one of those big monolithic applications and figure out where something went wrong, why it went wrong, and who, and then you're just, at that point, probably pointing fingers at somebody that was there 10 years ago and decided to write something from, 1995, right?
That never happened.
One of the best things about microservices is you get fast deploy times. So your windows are usually limited and fast build times relative to the monoliths.
Yeah,
So
you
really
guys
want to
saw
split everything out.
quickly that deployed for me when I pushed it out, and all I had to do was build it. And like I said, imagine my laptop is my CI/CD pipeline, right? So once that Docker image is done, it pushes into everything else is taken care of.
So I don't like we are just commenting about in our organization from monolith to microservices.
Yep.
But the challenge is what we are seeing nowadays is if you look into monolith, everything is in one single website. The moment when you burst them into individual microservices, now it became like 20 to 30 individual websites. So that's going to be another nightmare because for each and every website there needs to be a certificate, there needs to be an ID and everything. So how exactly are they going to address those issues?
I think you probably got to pay your architects a lot of money.
So, yeah, those are the real challenges now. Actually, the big companies that are facing into. And second thing is the performance issues. Like whenever you're talking about the individual data sovereignty, which is really good. But what is the approach? Like, are we going to with a database first approach or a code first approach?
I don't know. I'm old school. I use a database first approach. I need to see the data before I can tell you, before I can really create something meaningful for you. Because understanding the data is understanding your business is my approach, right? So if I get a good picture of your data, then I can kind of understand how to bring that application together and maybe get an idea of how to separate some of the duties of that application, right?
So does Azure provide kind of instrumentation and the service health by default? Are you going to do something? The services, whatever you wrote, how do you measure the service health? Like whether how?
So Azure has Azure has a bunch of great tools that you can.
We use Splunk in our office.
Back there.
Yeah. So I had a question about kind of decision making. So how do you decide what kind of goes into decision making on how small or large you make a grows and suddenly European customers need to be handled differently from the US customers, and you split that out. How do you make that decision and what kind of things you put in place?
Well, I mean, it's a process, right? So you got to understand what the problem is first, or what you're kind of up against, and then essentially pull back the layers of the onion, right? That's kind of the way I approach something like that. If I would introduce European customers to my data, do I necessarily need to separate anything? I don't know. I mean, that's maybe I just need locale and translation of my front end application, right? Maybe my microservices are fine. If all my it doesn't necessarily matter. It might not necessarily matter where everything lives at. If a customer if I would have European customers, though, I do have the ability to. One of the things that I would probably do would be select the proper region to deploy my services to. That would be closer to them, so they see, much better latency whenever they're hitting these services, right? So they get a better customer experience. So this might be one of the examples of a way to mitigate any sort of potential issues.
Your APIs, how do you handle versioning on those? So that like version 1 may work and you never take anything away when you go forward, but you may add things to it.
For these, actually, I didn't really write any versioning into
Well, I know
into
this
services.
But I mean, I'm thinking of you in practice where you're.
In practice, I mean, essentially you're going to break them out. Let me just pull up a controller. It really, again, it's going to depend on the needs of your team too. So, I mean, here's my route on my customer controller. I've got API controller. I may break it down and on each endpoint, if I add.
Sorry, can you zoom in again?
Yep.
Back?
So I can add a particular versioning directly on the endpoint itself. So if I need to create another get items v2, I'm not deprecating or dropping completely v1 endpoint, right?
But all of that goes into the same controller then. So you've got a controller with multiple versions of the same.
I think he's just trying to say you manage it on the application.
Yeah,
As opposed to the service level, the platform level. So.
I think it had a separate project.
Right, and what I was getting at is if you had V1 and V2 projects, that how would you handle that? I mean, and this is.
Are you talking about, well, I guess it just depends, and it depends on your case too. So are you talking about, I've got a version 1 endpoint that works just fine. It's been out there for only a couple months, but now I've got a client asking me to deliver me just a slightly different payload, right?
Right.
So I mean, I would manage that in the application, in the application itself. If you're talking about, are you talking about you've had an API, a version 1 API out there for 3 years, and you've got an entire application written around this version 1.
Right.
Now you're talking a different story. Now I might go and I might construct an entirely new, project.
And then put that in its own entirely different container then.
Most likely, and then bring it all under governance again. With, like I said, at that point would be a good opportunity to leverage the API gateway, because your API gateway consolidates all of those requests, and it can direct to version 1 and version 2. You actually, if you added an API gateway, you can version inside that gateway, so you don't even need to worry about versioning, exposing your versions to the world, right? You encapsulate that versioning inside your API gateway, and your customers are none the wiser. A particular customer gets one payload, a particular customer gets the other payload.
Can you briefly
I mean,
Does that manage the relational data between them?
you know, I could probably, so if, you know, when I create a customer, I end up with a unique customer ID, right? A unique ID. If that customer decides to place an order, I might let that order request actually hit my API, come all the way through to that particular database, and then any sort of change there might trigger some sort of referential integrity check on the customer ID from the customer service, right? If there's any sort of problem there, it's going to throw, I would throw some sort of SQL error and return back to the API, display something nice and pretty for the user. I mean, there's really what I would expect out of the event bus is maybe like a good example of what I've used the event bus for would be between, for communication between like an orders service and an actual like shipping third party, right? So that event bus, whenever an order hits the system, it automatically gets the event bus. You know, the event is fired, and the event bus sends that information to a shipping partner, right?
Alright.
That's probably a better example.
I guess then that leads me to think, because I try to minimize, traveling to and from the database, and typically with one database you can get a ton of data with one call, but it seems like you're making several calls just to get the final object. You just kind of have to weigh the options of doing four quick calls to small independent databases as opposed to, one call.
Yeah, absolutely. And I mean, it all comes down to how well your databases are architected too. Whether or not your DBAs are good at creating indexes. If you've got specific queries that are hitting that database very consistently, you should be indexed, right? That's going to reduce your time on your execution plans, and essentially reduce the amount of time it takes for that call to return to the front end.
Okay.
Any other questions? Back there.
More of a comment. Been working with a company, we've been doing microservices for about 2 years. And one of the key things for us is the decoupling of this data. So when it's all in one place, it all gets used for multiple things.
Yep.
And thus it's harder to change any one of those because you're breaking 5 other things down. By separating these things out into customer data is a customer flow engine and its data structure, and only the necessary data flows to your order, for instance.
Yep.
Your order system you may not want to have, you may want to minimize your privacy, customer private PII type data, so you may only want to send the first additional 5 letters of last name and the address, not the phone number, not the, into your order system, where, and then we'll move back to, hey, if someone needs that, they can look it up on the customer system. Now, the customer system can add 14 new features to their data and change their whole data engine if they want to, without impacting any of the other systems.
No, that's a very good point. That's something, yeah, I had that in mind. Obviously, I just completely spaced on mentioning, but PCI compliance is a good reason why you would probably want to segregate some of these into their own specific databases, right? If you've got sensitive data in one database, do you want to have to certify, everything, or do you just want to have to certify that one SQL server with that one particular database? To me, if I'm the person handling that, I just would much rather deal with the PCI people once on one database instead of certifying, everything under the sun for my application. Go ahead.
A little bit of a gear shift. I was curious, what's like the smallest level that you would make its own microservice? In terms of what the microservice is actually doing, what's the scope?
I think probably a good example of that would be something that might not even be tied to database, but an authentication service. So where that simply just handles my user information, right? That's just got my user, I would call it an identity service, right? So, I mean, it's got a very specific function, and that's log in or log out or kill my session or whatever, right? We're getting close on time here. Does anybody have any other questions? Cool. All right. Well, I know that Ari normally makes these videos available. I've got a repository that's public with this information in it. If anybody wants to take a peek at it, poke at it, whatever. And other than that, I would say if you're interested in continuing to look into this, where I've learned a lot was just been from Microsoft's documentation, oddly enough. Essentially, just a lot of reading from their side of things. I know we didn't talk a whole lot about AWS, but Amazon also has a lot of good webinars that they offer as well around this. Pretty much everything I showed you here today that I did on Azure is repeatable in AWS as well. I could take these same containers and deploy them in AWS. I have to tweak things a little bit, obviously, but it wouldn't give me any heartburn to do so. All right, thanks everybody.